Hey, okay, Algebra 2. We are going to start on our notes for today, which is solving log equations. So we're going to start using the properties of logs that we've been learning all about and that you just were quizzed on yesterday. So let's look at number 1. So we're trying now to get down to one log, because if we can get everything down to one log, then we can solve. So to do that, let's think about what we would have to do right here. Well, this is a log base 10 of 2 plus log base 10 of x. Well, we can combine them and rewrite them as one log. So how can we do that? Well, we have log 2 times x, because remember, when we're adding, when it's expanding and we're trying to condense the log, it goes to multiplication, is equal to 1. Okay, so we want to do our little roundabout here, but there's no base right there. There's no base. So what is that going to be? Well, we should know that that's an understood 10. So now when we rewrite this in exponential form, we get 10 to the first is equal to 2x. So now we solve for x. Well, to do that, we divide by 2 to both sides, because 10 to the first, what's 10 to the first? 10 divided by 2 is x, so x is equal to 5. Now make sure you check for extraneous solutions. So it's just a quick check. It's a quick check to come back up here and say, if I plug 5 back into my original, this is 2, so this is a positive, that's good. If I take that x and I put it as a 5, would that be a negative number? And the answer is no, 5 is not negative. So, check, we're good. We do not have any extraneous solutions right there. Okay, let's go to number 2. Number 2 is the same thing here. So, we have log of x plus log of 8. Let's condense that. So to condense that, we get log of x times 8 is equal to 2. Well, that looks weird. We don't like it like that. So let's rewrite it as log base 10 of x times 8 is equal to 2. And now let's do our roundabout and convert it into exponential form. So we get 10 squared is equal to x, 8x. So it's 10 squared, 100 is equal to 8x. Divide by 8 to isolate x. And we get 100 divided by 8. Well, let's simplify that. What can we simplify? Well, we can divide each of these by 2. And then we're left with 25 over 2 is x. You could convert that to a decimal, but I'm going to leave it right there. Go back and check for extraneous solutions. If we put a positive number in for x, is it going to change it to a negative? Nope. So we are good with example number 2. Okay, let's move to 3. So this time we've got a lot going on. We've got this exponent right here. We've got this subtraction. So we need to condense this. So I'm going to do it in 2 steps to walk you through all of it. So I'm going to go ahead and take my number in front of my log, and I'm going to write it as my exponent. So log base 5 of x to the third minus log base 5 of 4 equals log base 5 of 16. So the goal here is condense. We have to condense first. So now what we can do is we can do our subtraction. So remember from last week, or this week, log base 5 of x to the third over, subtraction is division, to the fourth equals log base 5 of 16. So now we have log base 5 on both sides, and we only have one of them. So that's exactly what we want. We want one log on each side, because once we do that, then we can cancel our logs, and we're left with x to the third divided by 4 equals 16. Now, all we're doing is just solving for x. Okay, so how do we do that? Well, we've got to get the 4 to the other side. So to do that, let's multiply by 4 to both sides. So those cancel, so we're left with x cubed is equal to 16 times 4 is 64. So now we still don't have x completely by itself. It's x to the third. So what can we do to get rid of that third? Well, hopefully everybody will say cube root x to the third. And if you look on the board, it says x to the x is equal to, well, we could rewrite 64. What's 64 rewritten? That's 4 to the third. It's on the board. And then we can cancel out our cube roots, and we're left with x equals 4. Again, go back and check for extraneous solutions, but there's nothing that's going to make that x a negative if our answer is positive 4. Okay, so that is number 3. So let's look at number 4. So again, we're trying to condense down to one log on both sides. So let's start condensing here. So we have log base 4, it's a positive, so it's x times x minus 6 is equal to 2. So now what I would do here is I would go ahead and distribute that x to both of these. So you're left with log base 4 of x squared minus 6x. And you can still put those in parentheses if you want to, is equal to 2. So now you have log on one side. So now we can do our roundabout and convert this to exponential form. So we have 4 squared is equal to x squared minus 6x. Well, we can simplify 4 squared into 16 is equal to x squared minus 6x. So I'm going to pause right there, make sure that we're all okay. You can ask each other questions. If you want to pause this video, if anybody has any questions, go ahead and ask each other, and maybe you can help each other since I'm not there. Okay, so if nobody has any questions, let's move on. So the next step that we can do here is we've got to solve this, and we have a quadratic. So we know that we have a quadratic here. So what we need to think of is quadratic. We need to think of maybe factoring, setting it equal to one side. So let's do that. Let's move our 16 over. So then we're going to have 0 equals x squared minus 6x minus 16. Now we need to think factor. Okay, so let's factor this. So what are factors of negative 16 that are going to subtract to give you negative 6? So we have 8 and 2, and it's got to be a negative 8 and a positive 2. So then we just set both of these binomials equal to 0 and solve for x. Okay, so at this point we have two answers. We have x is negative 2 and 8. But what do we have to do every single time? We've got to check for extraneous solutions. So go back to your equation and look at 8. If I put in my 8 here, okay, so this does not give me a negative, so we're good. And if we put in 8 minus 6, we get a positive 2. So that checks out because they're both positive. Okay, so 8 works. So let's go ahead, let's box 8 because we know, we know that 8 works. Okay, so now let's go check negative 2. So if we plug negative 2 right here, oh no, that of log base 4 of a negative number doesn't work. No, it doesn't. So that is extraneous. So we cannot use -2. So this is an extraneous solution. So the only answer that we have right here is 8. Okay, pause if you want to. Ask each other questions. Okay, so let's go, and what if they throw in some ln's for us? Well, first let's talk about what an ln is. It's a natural log. I think we've talked about this in class before. And an ln is the reciprocal of e to the x, okay? So when we do exponentials and we start graphing these, we will work a lot more with natural logs, well, ln's and exponentials of e's. But when we do this, let's go ahead and combine this. Let's condense it. So if we condense these, we would condense it down to ln of 2 divided by 3x plus 2 is equal to 1. So remember when I said that ln is the reciprocal of e? So what I want you to start thinking about is that this base, this understood base right here, is an e. So then when we go do our loop-de-loop, our roundabout, we get this. We get e to the first is equal to 2 divided by 3x plus 2. Okay, so pause this video if you need to ask each other questions. So at this point, e to the first, anything to the power of 1 is itself. So we can just write this as e to the first, or excuse me, just e, is equal to 2 over 3x plus 2. So we're trying to solve for x. So we're trying to isolate that x now. So there's a couple ways you could do this. You could put it over 1. I think this is the easiest one. So you can put e over 1 and then cross multiply. I think this would be the easiest for everyone. So if we cross multiply here, remember this is kind of in parentheses, so cross multiply here and cross multiply here. So then we get e, parentheses, 3x plus 2 is equal to 2. Now we still want to get that x by itself. This problem is kind of intense and it's long. So what we can do is we can multiply by e. So look what happens. 3 e to the x plus 2e is equal to 2. And now if I want to get e or x by itself, I need to move this -2. So if I move this or this 2 over to the other side, this cancels, and I'm left with 3 e to the x is equal to -2e plus 2. Okay, I'm getting close to the end. Okay, remember I want to isolate x. I want to get x by itself. So I can just divide by 3e to both of these, because that cancels, that cancels. So I'm left with x is equal to -2e plus 2 divided by 3e. Okay, that looks kind of ugly, but that is the answer. And so that's how working with ln's and e's might not be as easy as our log, because they kind of give us these funny looking answers. So we're going to go ahead and skip 6 for now. And I want you guys to flip over, example 6, I want you to flip over to start working on your homework. I'm going to do number 1 with you, and then I'd like you to try to do the rest on your own. So let's look at this. Is there any ln's in here that we have to be worried about? I want you guys to attempt 7 and 8 also work together to see. I don't think those are as ugly as the one in the examples. So let's do number 1 together. We have this 2. We need to move that. Is there any other exponents that we need to move? Not at this point. So we have log base 7 of x squared is equal to, okay, let's just combine these while we're at it. How can we condense those down to 1 log? You go log of 7 times 27 times 3. And I do not have my calculator on me, so I'm going to see what 27 times 3 is going to give me 81. So we have log base 7 of 81 is equal to log base 7 of x squared. So now at this point we have 2 logs on both sides with the same base. So we can cancel the log base 7 and just set the ofs equal to each other. So we have x squared is equal to 81. Well, now how do we get rid of and how do we solve for x? Well, we can square root both sides and we get x is equal to, don't forget when you take the square root of something, it's plus or minus that square root of 81. So the square root of 81 is 9. So now don't forget to go back and check. So we have x is equal to -9 and 9. But now we got to go check for extraneous solutions. So let's start with -9. If I were to plug, and we kind of need to go at this point because we need to see if this of is squared. Do you see that, how it's squared? Then if we put a -9 in here, that -9 becomes a positive. So it's not extraneous. That gives us a positive value. So we're good. All right, y'all attempt the rest. You have the rest of class period to work on this and get your homework done, and we will go over this on Monday. Hope y'all have a great weekend.